The Liskov Substitution Principle was introduced in 1988 by Barbara Liskov. It's not a complex principle, and you can see the definition on the screen. In simple terms, it means that a child class should be able to be used in place of a parent class without any errors. And I don't mean compilation errors or runtime errors. I mean, we should be able to replace the parent class with the child class without affecting the correctness of the program. Let me show you an example. There is a class rectangle with two fields, width and height. They are getters and setters, and the application is going to calculate the area of the shape. Let's run this example, and the shape is 200. There is also a class square. Square extends a rectangle and overrides the setters so that a square always has the same width and height. Now let's replace the parent class rectangle with square and run the example. The square is a rectangle and we didn't change any of the numbers, but the result is not 200 but it's 400. This seems like an unexpected behavior. The reason for this is that on line 7 we set the width to 10 and on line 8 we set the height to 20, but square setters always set both fields, so the result is 400. In this situation, the Liskov substitution principle is violated. We replace the parent class rectangle with the child class square, but this results in unexpected behavior. You can argue that we shouldn't implement the square setters that way, and you have a point, but the goal of this example is to give you an idea what is the Liskov substitution principle. And Liskov substitution principle is all about interfaces and contracts. Interfaces because we should model our classes based on behaviors, not on properties. And contracts because we should always consider the specification for our program. By following the Liskov responsibility principle, you can easily replace or extend your classes, and it also forces you to think how to model your classes according to your specification.